In this video, I'm going to show you how to solve the 10 hardest ACT math questions that have appeared on the test in the last year. Now, be warned, these are expert level topics. They are some of the hardest math questions that appear at the end of the math test, meant to stump even the best math students. Now, if you're aiming for a perfect or near perfect ACT math score, this video is really going to help you out. I'm going to teach you some rules, some equations, some tricks to help you solve some of the most advanced topics that appear on test day. All right, we're going to start off with a real stumper from a recent ACT. Now, before I solve this question, I recommend you grab yourself a pencil, a piece of paper, and your calculator, and give a shot at these questions before I go through and solve them. If you get stumped, of course, hit play, or if you think you solved it, hit play, and you'll see if you got it correct, or I'll explain exactly how to do this. Now, this one really confused students. Says, what is the units digit of 7 to the 123rd power? On test day, most people grab their calculators, try to punch it in, but you get stuck because it gives you this huge number and you can't tell what the units digit is. And if you don't know what the units digit is, the units digit is just the last digit in a number. So like say just a random number like 108, 8 would be the units digit. All right, so this is something that I like to call a repeating powers question. So 7s actually repeat the units digit as the powers go up. There's a pattern. 7 to the first is just 7. 7 squared is 49. 7 cubed is 243. 7 to the fourth is 2401. And then it starts to repeat. 7 to the fifth, if I use my calculator, it's 16,807. And 7 to the sixth, if we punch this in, I'll go ahead and do that. We're going to start to see this pattern repeat. 7 to the sixth is 117,649. So what we see is the units digit repeats. It goes 7, 9, 3, 1. Then we see 7 and 9, it's starting to repeat. 7 to the 7th power is going to end in a 3. 7 to the 8th power is going to end in a 1. So we can use this pattern to figure out what's the units digit going to be for 7 to the 123. So we can notice here, the trick here is go to the end of the pattern. So every time we have 7 to a multiple of 4, like 7 to the 4th or 7 to the 8th, it's going to end in a 1. So we need to find a multiple of 4 nearby 123. It turns out that 120 is a multiple of 4. So 7 to the 120 is going to end in a 1. So then we can count forwards in the pattern. So if this is my 120, I can basically count forwards. It'll be 121, 122, 123. So we can tell here that that value is going to end in a 3. So knowing these patterns for powers usually repeat in 4s are important. These are some really tricky ones, but they've been on the ACT a couple times and they're fair game for you to see on test day. Our second really hard question here reads, in the standard XY coordinate plane, a circle can be inscribed in the ellipse 9x squared plus 12y squared equals 108. Which of the following is the equation for the circle? So the challenge on this one is, one, a lot of students know what ellipses are. These guys are basically ovals. We'll learn about them in a second. And two, they don't know how to kind of draw an ellipse out in this form. So ellipses, just a basic kind of quick lesson here, is an ellipse is a shape that kind of looks like this as an example. It could be an oval, it could be horizontal, or it could be vertical, it could be at the center or not. So our basic rules for ellipses is normally we're going to have an ellipse at our equation is x squared over a squared plus y squared over b squared equals 1. And this quick lesson is not going to make you experts on ellipses, but this is an equation you should have memorized for test day. The a value down here we can think of as like the x radius. It's showing how far left and right the ellipse goes from the center. And the b value we can think of as the y radius. Ellipses in this form are always a plus, always equal to 1. Now, in order to get into this form, what I need to do is actually divide everything by 108 to make this equal to 1. So I'll write it out down here. So we have 9x squared plus 12y squared equals 108. And to get to this standard form, which is where we can graph this, we want to divide everything by 108. And if I do that, I can simplify it. So the 108 and the 9. Again, 108 divided by 9. I think it's 12, if I remember correctly. But I'm just trying to make sure I don't mess it up in the video here. 12. All right, perfect. So if I simplify this, it becomes x squared over 12. And then the 12 and the 108 becomes y squared over 9 equals 1. Now what this is telling me is the x radius, the a value here, is equal to square root of 12. So we're going to see this go left and right. The distance left and right is going to be equal to like root 12. It's going to be that distance. And then the b value here is going to be 3. And it's going 3 units up and 3 units down. So it's going to look like an oval like this. This is not the best oval we're drawing, but there you go. Okay. Now, it also tells the circles and inscribed. So a circle inscribed basically means it's going to fit perfectly inside the ellipse. So this is what our circle has to look like. And we know the circle has a radius of 3 because the distance up and down is 3. So now you have to know your circle equation. And the correct equation of our circle here is b, because the circle is center of the origin. And circles are written in the form x squared plus y squared equals r squared. We said the radius is equal to 3, so our r squared value is going to be 9. So all this stuff here is fair game. It's important to know the equations of circles. It's good to know the equations of ellipses. Ellipses do come up. They're one of those advanced topics. If you're aiming for scores of 30 and above, you need to learn how to handle these guys. Our third question here has to do with inverse functions. So it says the function f of x equals 4 to the 2x has an inverse function f inverse of x defined for all x positive base greater than 0 by which the following expressions. Now, we first need to remember how to find inverse functions. And I can rewrite this as just y equals 4 to the 2x. It's the same as like the f of x. And the trick for inverse functions is to find the inverse, we're going to switch the x and the y. So I can write this as x equals 4 to the 2y. Then we have to solve for the y here. The challenge here is that the y is up in the exponent, so how do we get at that exponent? Well, what we can do here is some logarithm rules. We can take the log of both sides. So the log of x on the right side is equal to the log of 4 to the 2y. Now, for log rules, if you have an exponent and a log, we can bring it to the front. So I can write this as log of x equals 2y times the log of 4. Now, I want to solve for y. So to get y by itself, I have to divide by 2 log of 4 on both sides. So the 2's will cancel out, the log 4's will cancel out, and what I'm going to get is log x over 2 log 4 equals y. So I'm close, but that doesn't quite look like any of these yet. So there's a little change of base rule that you should have memorized for test day as well. So if I have something like this, log base a of b, I can rewrite this as a log of big B over log of a. So it's the log of the big number on top over the log of the small number on the bottom. This is a great trick to know for a lot of questions that you can use for your calculator. If you have a fancier calculator, like I have a TI-84 here, other ones, there's a change of base button in here that you can use, but otherwise you can use this. Now, the trick here is we're actually going to go backwards because we're told, we can just look at this part here. So if I have log of x over log of 4, move this out of the way, I can rewrite this with our little change of base rule as log of our 4 is on the bottom and our x is on top. Because again, the big value b is the one that goes on top. That's why our x is the big value and the 4 is there. And then the 2 is on the bottom here. It's almost like this is, multiplied by 1/2. So it's 1/2 log base 4 of x equals y, which is how here we get to our correct answer of B on this example. So again, this is a really hard question. It's at the back of the test. It's meant to challenge you with super advanced log rules, algebra skills. Of course, it's another one that stumped a lot of people on test day. Hope you guys are enjoying the video so far. If you haven't already figured it out, I have an ACT math book I have written and published. It is by far the best and most up-to-date one for the test in 2024 and beyond. So I definitely recommend you grab a copy. There's links below. You can grab one on Amazon or a PDF copy straight from our website. With the book, if you get it, there's a 4-level system. Level 3 and 4 topics are super advanced topics. They're going to be challenging questions like the ones you're seeing in this video. So if you're aiming for a score of 30 and above, all you got to do is grab the book, work through those level 3 and 4 questions, and you'll be prepared to really do well in those last 15 or 20 challenging questions you see at the end of each ACT math test. For this question, we have to know how to compare across ratios. So we're told the ratio of x to y is 8 to 5, y to z is 15 to 22. We got to find this big mess. What is the value of 4x minus 2y over 2z minus x? So algebraically, this is no fun. So the trick here to make this easier is to be able to compare across ratios properly. So we know that our x to y is 8 to 5, and we know that our y to z is 15 to 22. Now, anytime we have a variable in both ratios, like here we have y's in both ratios, the trick to compare across ratios is make those values the same. Right now in the first one, in our first proportion, the y value is 5, and the second proportion, the y value is 15. We want to make those values match so we can compare across ratios. So if we multiply this whole first one by 3, our first ratio becomes 24 to 15, And then the second ratio is still 15 to 22. So we can see our y values here and here are now matching. When the y values match, we can compare across the ratios. So we can just think our x value is 24, our y value is 15, which we see on both these guys, and our z value is 22, because all those numbers make the ratios that were given in the question true. So now we can just take those values and plug them in to the value we're asked to solve. So we can just do 4, plug in our 24 for x, minus 2, plug in our 15 for y, divided by 2, plug in our 22 for z, and subtract our 24 for x and see what we get. So if we do 4 times 24 minus 2 times 15, we get 66 on top. If we do 2 times 22, that's 44 minus 24 gives me 20 on the bottom. Both those are divisible by 2, so I can get 33 on top, 10 on the bottom. You can see that matches our answer choice here of C. For our next question, we should definitely sketch this one out. So two sides of a triangle has lengths of 90 and 50 feet respectively. The angle formed by these two sides is 68. Which one is the length of the third side? So we go, well, I've got let's say these are my two angles here. So I have one that is 90. I have one that is, I'll make that actually shorter to be 50. So one here that is 50. I'm trying to find the length of this third side. I'll call this x over here. Now, I'm told that the angle here is 68 degrees. So how the heck do we do this? Well, to solve this, you have to know the law of cosines. And the law of cosines here is a squared equals b squared plus c squared minus 2bc cosine of a. Law of sines, law of cosines are very common at the back of the test in those last 10 or 15 questions. Definitely make sure you know those if you're aiming for super high scores. If you're watching this video, if you've never learned the law of cosines, of course you'll learn a little bit from this, but this might still be a little bit confusing, which again is okay, because if you don't know this, just if you see it on the test day, just take your best guess and move on, or of course try and learn it before you take the ACT. Now, this is our law of cosines. The way it works is this a value out front represents the side length, and that one is opposite the one that's in the angle. So here, we can think of the x here as like our a value, and we can think these other sides here are like our b and our c values in the equation. So if we set this up, it'll be a squared equals 90 squared plus 50 squared minus 2 times 90 times 50 times the cosine of 68 degrees. So now all we need to do is basically just use the calculator and solve. So we're going to do 90 squared plus 50 squared. I'll just do it out to make it a little bit easier. First one big step. So if we do that, we get 10,600 minus 2 times 90 times 50 is going to be minus 9,000 times the cosine of 68 degrees. That's equal to our a squared. We can solve that all out actually. So if we multiply that by the cosine of 68, make sure I'm in the right mode. So good, I'm in degree mode. And we do 10,600 minus that value. Let me do that, 10,600 minus 3371.46. We get a squared equals 7,228. We got to take the square root of both sides. So if we take the square root of that, we get a value that is like 85, almost exactly, very close to it. This one says closest to, so our correct answer here is going to be D. Again, this is a hard question. Do make sure you have this law of cosines equation memorized if you were going for those super high 34, 35, 36 type scores, because they do not always give it to you on test day. All right, this question here was probably one of students' least favorite questions, one that confuses them most. So here it says, counting repeating factors, how many prime factors appear in the prime factorization of 44 to the 4th? Now, let's first go over prime factorization, make sure you remember that. So if I'm doing the prime factorization of 44, we're basically making a factor tree. So 44 is 2 times 22. 22 here written as 2 times 11. This is as far as we go. So I can write the prime factorization of 44 as 2 times 2 times 11. Now the trick to this question is it's 44 to the 4th power. So basically, I have to write this 4 times. So this is my first 44. My second 44 would be 2 times 2 times 11. My third 44 is 2 times 2 times 11. And my fourth 44, can't really fit it here, I'll put it right here, 2 times 2 times 11. So if we count all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we write this in prime factorization and we're counting the repeating factors, the answer is B. There are 12 total factors. Question 60 is actually a question that if you know how to solve it is pretty easy, but it still stumps a bunch of students. And if you want to learn how to do this type of question and anything with mean, median, and mode, that's actually one of the free chapters that you can get the full chapter of my book and do, there's like 40 or 50 practice questions in that chapter in the free trial to my ultimate ACT math course. So there's a link to that below, you can check that out. Now, how do we solve this? What is the trick? Well, we're asked to find the median here. And the median, remember, is the middle number. Now, the trick with this one is the frequency table is telling us the number of basically numbers we have. So it's telling us we have 3 zeros, we have 5 students who got a number 1, 2 students picked the number 2, so we have to find the middle value. And I can't just be like, oh, it's in the middle down here, because we have to do with the frequency aspect. So again, the trick here is to find the median. Little trick is add 1 and divide by 2. So if we add 1 and divide by 2, so we get 38 plus 1 is 39 divided by 2, that gives me an answer of 19.5, which tells me that the median is going to be an average of the 19th and 20th students. Now what that means is think of them in order. If we had all these students and we started at the very lowest and counted that as the first student and went to the highest score and counted that as the 38th student, I'm looking for the 19th and 20th students. So again, if we think we line everybody up, you're starting to cross your way to the middle. Numbers 19 and 20 would make the median out of this group of 38. So what we want to do is we want to find where are the 19th and 20th students located and what are their scores. So we can just start adding up. There are 3 students here. There are 5 students here. If we add those all together, 3 plus 5 plus 2, we have 10 so far. This is going to be my 11th student, plus 7 more is going to get me up to 18 students. So my 19th and 20th students are going to be some of these students here, and those students had a score of 5. Since both the 19th and 20th students had a score of 5, that means that our median, which is the average of those two, is still going to be 5. So that's how we get to the answer here of C. 55 is a definite stumper at the back of the test. We're given this rational equation x over x plus 2 plus 3 over x minus 5 equals x plus 1 over x squared minus 3x minus 10, and ask which of these has the same solution set. So it's pretty confusing to even know what this is asking you. So the trick to this one is it's asking you, can you combine these fractions and do the math out here correctly? Now, in order to make these fractions and kind of solve this out, make them look the same, we have to get a common denominator. So to do that, we have to recognize that this here, our x squared minus 3x minus 10, is the same as x plus 2 times x minus 5. So to make these all have a common denominator, I can multiply my first value here by x minus 5 on top and on bottom of the fraction, and this one by x plus 2 on top and on bottom. And I'll kind of write this out. So we have x over x plus 2. We have to multiply this by x minus 5 on top and on bottom. And then we have 3 over x minus 5. I have to multiply this plus x plus 2 on top and on bottom. And the right side is already divided by our x squared minus 3x minus 10, which remember is the same as x plus 2 times x minus 5. And there's an x plus 1 on top. So if we do that math out, and I multiply these guys together, it becomes x times x minus 5 over, if I multiply these two together, again it's x squared minus 3x minus 10 plus 3 times x plus 2 over x squared minus 3x minus 10 equals x plus 1 over x squared minus 3x minus 10. Now, if we're looking for the same solution set, if this on top matches, this is where the solution set is going to come from for these types of questions. So we can see that this actually directly matches what we see with E. So E is going to be the correct answer because if we solve the top of that, that's going to tell us the zeros for like this entire equation. If we take away the fraction, it's going to have the same solution set. So again, there's a lot of advanced math going on here, definitely a hard question, but that's how we get to E. For question 51, we have to introduce the idea of expected value. This one says the numbers of the sides of a fair 12-sided dice are shown in the table below. If the dice is rolled one time, what is the expected value for the number that appears? So here, what we see is the table's a little bit weird. It tells us the number on the left side that appears on the side and the number of sides. So it's telling us that 2 sides of the dice have a 1 on it, and 3 sides of the dice have a 2, 4 sides of the dice have a 3, 2 sides have a 4, and 1 side has a 5. And we're asked to find the expected value. Now, the expected value is this kind of combination of like probability and payout. So to find the expected value, what we're going to do is, again, we want to find basically the probability of each outcome occurring and multiply by some sort of value. And this one, actually, we're just going to multiply it by the number on the side because we're trying to find the expected value of the number that appears. So let's start with this first one up top, the number 1. So there's 2 sides of the dice that have a 1. So there is a 2 in 12 chance that when you roll the dice, you're going to get a 1. So 2 out of 12 times, we're going to get a 1. Now, the next time, we could also get a 2 on the dice. And there are 3 sides of the dice that have a 2. So 3 of the 12 sides, or 3 out of every 12 times you roll the dice, you're expected to get a 2 on there. Now, if we keep repeating this process, there are 3, the number 3 is on 4 sides of the dice. So there's a 4 out of 12 chance that when you roll the dice, we're going to get a 3. If we keep doing this process, we're going to keep adding. So I'll just go down to the next line so we have more space. There are 2 sides that have a 4. So there's a 2 out of 12 chance we're going to roll a 4. Then there's only 1 side with a 5. So there's a 1 out of 12 chance we're going to roll a 5. So to solve this, what we do is we add all of these together. So it becomes 2 out of 12 plus 6 out of 12 plus 12 out of 12 plus 8 out of 12 plus 5 out of 12. So if we add those all together, we can use a calculator, make it easy. 2 plus 6 plus 12 plus 8 plus 5 gives us a value of 33 over 12. If we do that in our calculator, we find that our expected value is 2.75. So if you understand this question, expected value questions are ones, they don't come up a ton on the test, but they are fair game, and that's one, again, you should know for the back of the test. If you see it in those last 10 or 15, once you know how to do these, they're actually not that hard. It's just learning how to set up these questions and solve. Question 47 here is a weighted average question. This is a really important one to know how to do. It comes up a lot late on the test. This is also covered in the free trial I mentioned earlier to that math course. So you can go check that out. You'll learn a bunch. There's also everything you need to know about matrices in there, which is not in this problem set, but also a common topic that stumps a lot of students. Now, this one says a bucket contains 8 liters of a 15% sucrose solution, and it's mixed with 22 liters of pure water to produce a new sucrose solution. What is the percent of the new what percent of the new solution is sucrose? So our little weighted average here is we go, well, there's 8 liters of 15% sucrose, and then there are 22 liters of 0% sucrose. We're going to divide that by the total amount of water. So we're going to do 8 plus 22 to find whatever the new percentage is. And the reason this works is on top, we're finding this is our sucrose. So we're finding the amount of sucrose we have. And on the bottom, this is our total solution. So if you can find the total sucrose on top and the total solution on the bottom, that's going to give us the percent sucrose. So all we're going to do is just do the math here. So we can do 8 times 15. This 22 times 0 is going to be 0. So it's going to be 120 divided by 8 plus 22 is going to be by 30. So if we multiply that out, 120 divided by 30 is going to give me a value of 4%. So our correct answer here is going to be A. Hope you guys enjoyed the video and learned a lot along the way. Now, if you want some more free ACT prep with me, go sign up for the free trial of my Ultimate ACT course, which is a self-paced online course that you can use to get the same experiences working with me as your private tutor. So in the free trial, there's a bunch of grammar rules you can learn to boost your English score. There's actually 2 free chapters from my ACT math book I talked about earlier you can use and see videos of me teaching you everything. So it's a quick way to boost your math score. There's also some great tips for reading and science. So it's totally for free. You guys can go in there and check it out. And of course, I hope to see you in the full course, which has over 70 hours of videos of me teaching you everything you need to know for the ACT. Other than that, please like and subscribe. Check out my other videos for more free ACT prep content to help you guys do well on test day. If you have any questions, please let me know in the comments, or just a quick thank you if you guys enjoyed the video. Other than that, as always, like, subscribe, and I'll see you guys next time.